Good morning. Today's quote is very important. Take care of your body. It is the only place you have to live. Take care of your body. It is the only place you have to live. Today's word is naivete, lack of sophistication or worldliness. You can say the state of being naive. He looked surprised by the naivete of the question and offered a wry smile. Now exercise 5.1, I think we have to solve sum number 12. We'll be doing first part, second for homework. Show that the following points are collinear. Points are given, okay. Now suppose given points are ABC, then we will find AB bar and BC bar. If we could express one vector in terms of other, vectors must be collinear, that is parallel. But as far as AB bar and BC bar are concerned, they have point B in common. So the 3 points must be collinear. If it is not possible to express one vector as a non-zero scalar multiple of other, means vectors are not collinear, that is parallel. So points are not collinear. Okay. So write down. PV is the standard short form of position vector. So position vectors of points, actually in exam you are supposed to mention those points with coordinates. Here I am writing directly. Position vectors of points A, write the coordinates, B, C are respectively A bar. Now what are the coordinates of capital A? 3, 2, minus 4. So what is small a bar? 3 I cap plus 2 j cap minus 4k cap. Write down B bar. B bar is 9I plus 8j minus 10k. And what is C bar? It is minus 2I minus 3j plus k. We already discussed what is AB bar. AB bar is basically position vector of B with respect to A. So it is B bar minus A bar. Substitute B bar and A bar and tell me what is AB bar. Similarly, find out BC bar, which is C bar minus B bar. So AB bar comes out to be 6I cap plus 6j cap plus 6k cap. Just check this. Okay. I can say this is number 1. What is BC bar? C bar minus A bar. So it is minus 11I cap minus 11. I think the third part should be, just check this, minus 6k, not plus. So minus 11I cap minus 11j cap, then plus 11k cap. Now just listen to me. So I can say BC bar, see what I am doing. I am writing minus 11 by 6. Why? So that I can write 6I cap, okay, plus 6j cap minus 6k cap. See, I have written the same in required form. Now I can say this is minus 11 by 6 AB bar. Reason from 1. See, I'm not saying this is the only way in which you can present the solution. You may say take 6 common and so on. But our aim is to express BC bar as a scalar multiple of AB bar. So I am writing after this. So BC bar is a non-zero scalar multiple, non-zero scalar multiple of AB bar. Therefore, BC bar parallel to AB bar, but they have the point B in common. But they have point B in common. Therefore, points ABC are collinear. This is how you have to present. Sum number 13. If the vectors 2i cap minus qj cap plus 3k cap and 4i cap minus 5j cap plus 6k cap are collinear, find q. Now vectors are collinear, so their components are proportional. Now you may ask me why. The reason is simple. These vectors are collinear, so this vector equal to k or lambda, not k because k is already used, lambda of this vector. But here I cap has component 2 and here 4 lambda, right? And therefore we say that the components must be proportional. Don't say equal, say proportional. So what is the component of I cap in the first vector? 2 upon component of I cap in the second, and so on. Now we need not write even third because there is only one unknown. So what is q from this? 5 by 2. Note that we can say that components are proportional if and only if vectors are collinear. If they are not collinear, components will not be proportional. You can also call these as coefficients of I cap, j cap, k cap, but it is better if you use the word component. So this is for sum number 13. Now sum number 14. Are the 4 points A, B, C, D coplanar? Justify your answer. See, logic is very simple. From the 4 points, we will obtain 3 vectors AB bar, AC bar and AD bar. If we could express one vector as linear combination of remaining 2, then vectors must be coplanar, but they have point A in common. So all the 4 points must be coplanar. Right now. Solution for sum number 14. For 15th, we are going to discuss the solution. We will not write solution of the next sum in the class. You have to write the solution after the lecture. Okay, write down. The position vectors of the given points. I'm going to dictate first part. The position vectors of the given points A, B, C, D. See, when I say points, you have to use capital letter. The position vectors of the points A, B, C, D are A bar, write down, small a bar equal to I minus j plus k. See, you may say, so this is not 14th, this is 13th. Okay, then we are doing 13th sum. A bar equal to I minus j plus k. B bar equal to minus I plus j plus k. B bar equal to minus I plus j plus k. Just check this. C bar equal to I plus j plus k. Actually, it is I cap plus j cap plus k cap. And what is d bar? It is 2i cap minus 3j cap plus 4k cap. Now tell me what is AB bar? AB bar is basically B bar minus A bar. Tell me all this. AB bar followed by AC bar and then AD bar. Find out these three. AB bar is minus 2i plus 2j, is it? Then AC bar is 2j. And what is AD bar? It is I minus 2j plus 3k. Now you have to say, let if possible. See, we are asked to verify. We are not asked to prove that points are coplanar. Are the points coplanar? Justify your answer. So we will say, let if possible, AB bar equal to XAC bar plus YAD bar. There should be scalars X and Y such that AB bar is XAC bar plus YAD bar. That is, we should be able to express one as a linear combination of other two, right? But we are not sure. That is why we are saying let if possible. Now substitute. So 2i minus 2j. What is that? Minus 2i plus 2j rather. Minus 2i plus 2j equal to x 2j plus y I minus 2j plus 3k. I write this as minus 2i plus 2j plus 0k equal to yi plus 2x minus 2y. I'm rearranging the terms. 2x minus 2yj plus 3yk. Okay. Now equate the components, or you can say by equality of vectors. Y equal to minus 2 and 3y equal to 0. That is y equal to 0. I'm just equating these two only. This is not possible. How can there be two different values of y? This is not possible. So can we draw the conclusion? Means it is not possible to express one as linear combination of other, and therefore vectors are not coplanar, so points are non-coplanar. Therefore AB bar, AC bar, AD bar are not coplanar. Therefore, points A, B, C, D are non-coplanar. Right now. The next one, maybe this is question number 14 in your textbook. Express minus I cap minus 3j cap plus 4k cap as the linear combination of the vectors 2I cap plus j cap minus 4k cap, 2I cap minus j cap plus 3k cap, and 3I cap plus j cap minus 2k cap. We denote the given vectors by a bar, b bar, c bar, and p bar. Then we say that let p bar be xa bar plus yb bar plus zc bar. Now we can get three equations. How? By equating components of I cap, j cap, and k cap. For that, on the right hand side, I have written a single term in I cap, which is what? 2x plus, see the cursor, plus 2y plus 3z, and so on. Now these two vectors are equal, so components must be equal, right? Now you will ask me, why aren't you saying proportional? Because in the previous sum we said proportional, because in that case two vectors were not equal. One vector was scalar multiple of other. That is why we said that they are proportional. Here vectors are equal. So these are the three equations. Now choice is yours how to solve these equations. I hope you will not say matrix method. It is better that you use Kramer's rule for this. So what is D? It is determinant of coefficients of x, y, and z. It comes out to be minus 9, not equal to 0. So we can solve these equations. What is dx? Determinant obtained from D. How? By replacing coefficients of x, 2, 1, minus 1, which are in the first column, by constant terms, minus 1, minus 3, 4. You should know how to use Kramer's rule. So dx is minus 18. Similarly, dy is minus 18 and dz is 27. So what is x? Dx by d, that is 2. What is y? Dy by d, that is 2. Z, dz by d, that is minus 3. So what is p bar? 2a bar plus 2b bar minus 3c bar. Now we are going to discuss section formula. Proof can be asked. Section formula for internal division, section formula for external division. Now, what is the difference between internal division and external division? Consider points A and B. If the point P lies on segment AB, it is said to divide segment AB internally in the ratio AP is to PB. Note that if we consider vectors, then AP bar and PB bar are in the same direction. Suppose the point Q does not lie on segment AB but lies on line AB. That is, the betweenness is A dash B dash R or R dash A dash B. The point R is said to divide segment AB externally, in which ratio? AR is to RB. If you consider vectors AR bar and RB bar, you will notice that they are in opposite directions. Okay, so I repeat this part. If a point lies on segment, then it is said to divide the segment internally. If point does not lie on the segment but lies on the line, then it is said to divide the segment externally. Okay, usually the ratio is taken as m is to n, both in case of internal and external division. So we are going to discuss first theorem, section formula for internal division. What is that theorem? If A bar, B bar, and R bar, small r, if A bar, B bar, R bar are position vectors of the points A, B and R respectively, and R divides the line segment AB internally in the ratio M is to N, then we have to prove that R bar equal to MB bar plus NA bar upon M plus N. See, you can remember this formula easily because in 9th standard you have obtained this using x and y coordinates. What was that formula? X equal to mx2 plus nx1 upon m plus n. In fact, after proving this, we will actually write the formula using Cartesian coordinates. We'll get the same. Okay. So we have to prove this. R bar equal to mb bar plus na bar upon n plus n. Let A bar, B bar, R bar be the position vectors of the points A, B, R respectively with respect to some origin O. Okay. Now R divides segment AB internally in the ratio M is to N. That is, listen to me carefully, that is AR upon RB equal to M upon N. Okay. Now cross multiplication gives NAR, do not use dot, NAR equal to MRB. Note that AR bar and RB bar are in the same direction. So I can say NAR bar equal to MRB bar. Now what is AR bar? Position vector of the point R, which is R bar, minus position vector of the point A, which is what? A bar, equal to M. What is RB bar? Position vector of point B, which is B bar, minus position vector of the point R, which is R bar. Now we have to solve this equation for what? R bar. Open the bracket. So NR bar minus NA bar is MB bar minus MR bar. Okay. What next? I can say that from this MR bar plus NR bar equal to MB bar plus NA bar. I have just rearranged the terms. Now take R bar common to get in bracket M plus N. So M plus N R bar is MB bar plus NA bar. Now M plus N not equal to 0. So R bar is what? MB bar plus NA bar upon M plus N. Is that clear? Now, if I take A as x1, y1, z1, B as x2, y2, z2, then it can be easily proved that the point R, point of internal division, if its coordinates are x, y, z, then x is nothing but what will be x? It will be mx2 plus nx1 upon m plus n. Similarly, what is y? my2 plus ny1 upon m plus n, and one more coordinate z equal to mz2 plus nz1 upon m plus n. Now there are two corollaries of this. The first one is midpoint formula. R can be the midpoint of segment AB. It need not be, but it can be. So in that case, ratio of division is 1:1. So what is R bar? It is nothing but 1 B bar, okay, plus 1 A bar upon 1 plus 1. Now addition of two vectors is commutative. So it is just A bar plus B bar upon 2. Okay, so this is midpoint formula. If you remember, we have already obtained the midpoint formula by considering uh, collinearity of vectors. Now it is centroid. Let us obtain centroid formula. Centroid is point of intersection of three medians of a triangle. Okay. So these are the medians. Vertex A with position vector A bar, vertex B with position vector B bar, vertex C with position vector C bar. Suppose uh, M is the midpoint of side BC. Now the point of concurrence is called as centroid. You should know that centroid divides every median in the ratio 2:1 internally, the greater part being towards the vertex, that is apex. Okay. Now, can you tell me position vector of the point M bar? M is midpoint of BC. So it is B bar plus C bar upon 2. It's a corollary of section formula for internal division. So obviously we'll be using that. Okay. So M bar is B bar plus C bar by 2. Now position vector G bar of point G is what? G divides AM internally in which ratio? 2:1. So can you tell me what is G bar? It is 2M bar plus 1 A bar upon 2 plus 1 Y. Section formula for internal division, MB bar plus NA bar upon M plus N. So it is 2. What is M bar? B bar plus C bar upon 2 plus A bar upon 3. If you rearrange the terms, if you use commutative and associative law, then what is G bar? It is A bar plus B bar plus C bar upon 3. Is that clear? So this is nothing but section formula for which division? Rather, section formula uh, for internal division, and this is the second corollary, that is centroid formula. Okay. Now it will be the centroid formula using Cartesian coordinates. For that, I will have to say let capital A be x1, y1, z1, capital B be x2, y2, z2, capital C x3, y3, z3. Then the centroid G x, y, z is given by what? What will be x coordinate? x1 plus x2 plus x3 upon 3. You already used this. It was 2D geometry, so it was for only x and y. Now one more coordinate, z coordinate, is added. Okay, so this is nothing but section formula for internal division. Now what is section formula for external division? Let me explain. Section formula for external division. A, B, R. Between this is A dash B dash R. You can also consider R dash A dash B. So this is O, A bar, OB bar, R bar. And what are the directions? This is AB bar, this is RB bar. Okay, good. Now point R divides join of points A and B, that is segment AB, externally. But note that ratio should be taken as AR upon RB, that is M is to M. Okay. Now cross multiplication gives NAR equal to MRB. Now next step is important. See, M and N are positive, but we know that AR bar and RB bar, AR bar and RB bar are in opposite directions. So if I want to use vector, I should say NAR bar is minus MRB bar. I hope you are getting this step. Why minus? Because they are in opposite directions. N and M are positive, and that is why you may say minus NAR bar equal to MRB bar. One and the same thing, right? Now this is N. What is AR bar? R bar minus A bar equal to minus M. What is RB bar? B bar minus R bar. Okay. And therefore, NR bar minus NA bar is minus MB bar plus MR bar. Our aim is to obtain R bar. Accordingly, rearrange the terms. So MB bar minus NA bar is nothing but MR bar minus NR bar. Take R bar common to get M minus N. Now M cannot be equal to M because it is a point of external division. And therefore, what is R bar from this? It is MB bar minus NA bar upon M minus N. So this is the section formula in case of external division. Now can you tell me section formula using Cartesian coordinates? If A is x1, y1, z1, B is x2, y2, z2, and the point of division is taken as x, y, z. I will just write for x coordinate. What will be x? It will be mx2 minus nx1 upon m minus n. Okay. Now in exam, if you are asked to find the ratio and if type of division is not mentioned, we assume internal division. If we get positive ratio, means what we have assumed is correct. If we get negative ratio, suppose we get answer as -3:4, then you have to say that point divides segment in the ratio -3:4, or you can say point divides segment externally, but in that case ratio you have to say 3:4 and not -3:4. Okay, so this is about section formula. Exercise 5.2. Find the position vector of the point R which divides the line joining the points P and Q, whose position vectors are 2i minus j plus 3k and minus 5i plus 2j minus 5k in the ratio 3:2. First part internally, second part externally. P bar, Q bar are given. Ratio is given as 3:2. Now first internal division. So by section formula for internal division, R bar equal to MB bar plus NA bar upon N plus N. Substitute. You have to simplify patiently. Minus 15i plus 4i. So minus 11i and so on. So what is R bar? Minus 11 by 5 I cap plus 4 by 5 j cap minus 9 by 5 k cap. So what is R? Minus 11 by 5, 4 by 5 minus 9 by 5. For external division, R bar is MB bar minus NA bar upon M minus N. You should get minus 19i plus 8j minus 21k. So the coordinates of R are minus 19, 8 minus 21. Second, find the position vector of midpoint M joining the points L 7 minus 6 12 N 5 4 minus 2. So I will say L bar. What is L bar? It is 7i minus 6j plus 12k. And what is N bar? N bar is nothing but 5i cap plus 4j cap minus 2k cap. What is given? Midpoint M, its position vector is to be obtained. Therefore, position vector M bar of midpoint M is given by what? M bar equal to L bar plus N bar upon 2. Substitute L bar and N bar and tell me the answer. So what is M? 6 minus 1, 5. Sum number 3, if the points A, B, C are collinear, then find the ratio in which the point C divides segment AB and find the values of P and Q. So these are the points. Let point C divide segment AB in the ratio M is to N. You will notice that x coordinates of all the 3 points are given, right? So I will say applying section formula on x coordinate. So x is mx2 plus nx1 upon m plus n. X coordinate of C is minus 3. What is x2? X coordinate of B. And what is x1? X coordinate of A. Okay. So I get m upon n as what? Minus 3 is to 1. So my conclusion is the point C divides segment AB externally. Now when I use the word externally, I should say in the ratio 3 is to 1. Now I will use this ratio on remaining 2 coordinates to get the values of P and Q. Right up. Yes, so we have to say that ratio is 3 is to 1, but we have to add that C divides AB externally. I hope this is clear to you. Okay. I repeat, why to choose x coordinate? Because x coordinates of all the 3 points are known. Now, once we get the ratio, we can apply section formula on y and z coordinates. So this is y coordinate of C. 3 y coordinate of B minus 1 y coordinate of A upon 3 minus 1. So this gives me Q equal to 2. Similarly, P equal to 9. You have to write answer separately that C divides segment externally in the ratio 3 is to 1, P equal to 9, Q equal to 2. So that's it for today.